Hello everyone, I am Rupa, working as an assistant professor in Gokaraju Rangaraju Institute of Engineering and Technology. Now I will discuss about attribute-oriented induction. Attribute-oriented induction is an alternative method for data generalization. Actually, data generalization is a process that abstracts a large set of task-relevant data in database or data warehouse from a relatively low-level concepts to high-level concepts. Within this data generalization, it abstracts the large set of task-relevant data either from a database or from a data warehouse, relatively from low-level concepts to high-level concepts. There are two approaches for efficient and flexible data generalization. We have one is a data cube, that means OLAP approach. Second one is a attribute oriented induction approach. We already discussed about in a last video as a OLAP approach. That means OLAP operations as slice, dice, roll up, drill down, and some of the materialization concepts for data cube. These are all comes under the data cube approach. Now we will discuss about the attribute oriented induction approach as a data generalization. First we'll see attribute oriented induction approach for data characterization. Data characterization is one of the data mining functionality. The purpose of this functionality is it will give the general characteristics of the data. It will give the general characteristics of the data. Okay, for this approach, we will see what are the steps are involved for this one. Generally, the OA is basically a query-oriented generalization based online data analysis technique. Okay, we will see the steps for this AOI approach. The first step is first we need to collect the task relevant data using data mining query language and relational database query and construct the initial working relation. The first step is we need to collect the task relevant data using data mining query language and relational database query and construct the initial working relation. The second step is we need to perform a data generalization by examining the number of distinct values of each attribute. This is done by using two methods. One is attribute removal or attribute generalization. Okay, we will see when we go for the second step how we can apply the attribute removal or attribute generalization while taking an example. Okay, the third step is apply aggregation by merging identical generalized tuples and accumulating their respective counts. Here we need to apply the aggregation on the merging identical tuples. In the fourth step, the resulting generalized relation can be mapped into different forms of presentation to the user. Okay, the fourth step is a visualization presentation for the user. Okay, all these are the steps involved within the attribute oriented induction approach. So we will take an example and I will discuss about the how we can perform all the steps of attribute oriented induction. The example is here we need to describe the general characteristics of a graduate students in the university database for a given attributes as name, gender, major, birthplace, birth date, residence, phone number, GPA. These are all the attributes have to be available. We need to describe the general characteristics of a graduate students in the university database. First step is we need to collect the task relevant data by using data mining query language. Okay, we can write a query as use big university database. This is the database and mine the characteristics as science students in relevance to the all the attributes name, gender, major, birthplace, date, birth date, residence, phone number, GPA. From student, where status in graduate. Okay, like this we can write the data mining query language using this database and mine the characteristics of a science student in relevance to the all the attributes from a student and where the status is a graduate student. Like this we can write the query. And next one is whatever the task, fetch the task relevant data set of data using SQL statement. That means whatever the data we are fetching by using data mining query language, we can transform into the relational data into SQL statement. We can write a query in a way as a use big university database, select all the attributes as a name, gender, major, birthplace, birth date, residence, phone number, GPA from students, where status in, you can write the all the graduate branches: MSc, MBA, BSc, BA, BCom, MCom, MCA, MBBS. Now the data is stored in a table called as initial working relation. Okay, we can use the relational database statement as SQL statements, and we can retrieve the data in a form as a table as the initial working relation. Okay, the first step is completed. We are retrieving the task relevant data and created a table called as initial working relation. This is the output of the first step. Okay, this is a initial working relation. It contains all the attributes: name, gender, major, birthplace, birthday to up to GPA. Okay, next second step is within this step we need to perform data generalization using two methods as attribute removal and attribute generalization. That means we need to find which attributes are relevant and which attributes we need to remove from the corresponding data. That means initial working relation table. Okay, for attribute removal we can follow as a remove an attribute A if there is a large set of distinct values of A, but one, there is no generalization operator on A. Second, A's higher level concepts are expressed in terms of other attributes. Okay, by using these two principles we can remove the attributes. Okay, if A has to be contain large set of distinct values and there is no generalization operator for A, and the A is higher level concepts are expressed in terms of other attributes, then we can remove that one. We will see with an example. And then in attribute generalization, if there is a large set of distinct values for A and there exists a set of generalization operator on A, and select an operator and generalize A. Here, if there is a large set of distinct values for A, for attribute A, and there exists a set of generalization operator on A. Okay, generalization operators has to be exist on attribute A, then select an operator and generalize A. Okay, the threshold for attribute threshold control is threshold default range from 2 to 8, and for generalizer relation threshold control is control the final relation rule size, the default is 10 to 30. Okay, by using these two threshold values we can remove the attributes and we can retain the attributes by using attribute removal and attribute generalization. Okay, we will see. We have what are the attributes has to be available here. We have a name, gender, major, and so on up to GPA. Okay, for name, this is a large number of distinct values and no generalization, right? Okay, we have different kinds of characters has to be available, different names has to be available, all the distinct values has to be available within this one. We can remove this attribute. And the gender, only two distinct values has to be available, we can retain that one. Okay, either it may be a female or male, and you can retain that one. And for our next attribute, major, generalized values into major has to be contained as a science, English, arts, and etc. We can retain that one. Why? Because it does not reach the threshold value. The threshold value is here. The threshold value is 2 to 8. Okay, it is not exceeding the threshold value. That's why we can retain that one. For the birthplace, it has a large number of distinct values, and concept hierarchy can be defined as a place. Concept hierarchy contains city, state, and country. The number of distinct values for a birthplace is greater than the threshold value. That's why we need to retain this one. We can take a country, it is less than threshold. So the birthplace should be generalized as a country. Okay, we need to moving on to the higher level. Then we can retain this one. Okay, here within this name we are applying the attribute removal. Within this birthplace we are applying data generalization. Sorry, attribute generalization. For birth date, the concept hierarchy existed as a date, age range. So it is generalized as a age range. Instead of taking it as a birth date, we can generalize it to age range. That we need to retain this attribute. And for residence, the concept hierarchy is street, city, state, and country. It is generalized to state, and we can retain this one. For phone number, it contains large number of distinct values and there is no generalization. We will remove this attribute. And for GPA, numerical values grouped into descriptive values, and we need to go for using as a generalization. We can retain this one. Okay, whatever the numeric values has to available for GPA, that has to be converted into the descriptive values. That's why we need to retain this GPA. Now, which attributes we are removing here? We are removing name, and one more is a phone number. Now, we'll see. This is an actual initial relational working table. From this one we are removing name and one more is a phone number. After removing this one, we need to go for the third step as a generalized tuples. Okay, we need to change the what are the generalized tuples has to be available. Okay, gender is as it is available, major is there, and in place of this birthplace we are keeping it as a country, that means birth region, and in place of birth rate we are replacing it as a age range. Okay, that has to be there, and residence, in place of residence we can keep it as a state, and phone number has to be removed, and GPA has to be converted numeric value into descriptive value. So finally we are keeping that count. This is the generalized tuples has to be available within third step. And in a fourth step, the presentation of results in different forms. Here we can represent in a different forms as a cross tab, list, in any other chart representation. Here the example is a cross tab has to be represented for corresponding gender and a birth region. What is the count for the students data? Okay, this way we can represent the presentation. Thank you. This is about attribute oriented induction. Within this attribute oriented induction, we need to go for the steps as a first you need to find the task relevant data by applying data mining query language and transform that to data mining query language into relational database as a SQL statement that will give the table as an initial relation working table. After getting this initial working relation table, then we need to apply the attribute removal or attribute generalization, and what are the attributes are relevant we will keep that one, remaining has to be removed, and some of the attributes has to be generalized into the higher levels. Okay, after making this one we can present data in a way as a visual presentation as a cross tab, list, or any of the chart representation. Okay, like this we need to apply all the steps for attribute oriented induction. Thank you.